Hello everyone, welcome back to my channel. This is Hitesh Agarwal, and today I want to start on checkpoint 1. My very first topic is ARP. So let's get straight into it. My agenda for today is to introduce ARP to everyone, and I'm going to follow that up with why we need ARP. And at the end, I'm also going to explain how ARP works through an example on Packet Tracer. So, introduction to ARP. Uh, ARP stands for Address Resolution Protocol. It is mainly used to discover layer 2 addresses, which are MAC addresses, of a known layer 3 address, which is an IP address. This ARP, the protocol, is very crucial to know, to have communication between a network, inside a network. And it has two kinds of messages. It has an ARP request and an ARP reply. ARP request is sent by the host to the client to ask for its MAC address. And usually it's a broadcast message. By broadcast, I mean the destination MAC address will be all Fs. And our reply will be the message from client back to the host. It will be a reply to the initial ARP request. And in this ARP reply, it will tell the host that, hey, this is my MAC address. And it's generally a unicast message. And this is the topology that we're going to be working with today. This is what I'm going to use to explain how ARP works, also demonstrate how ARP works. So here we have our main host, PCA and PCB. We're going to transfer data between these two, and I'm going to show you how ARP works. So here we are on our topology, and let's say PCA here wants to send some data to PCB, and it creates an IP packet. It says, hey, my source IP is 192.168.1.1, and the destination IP is the IP of PCB, 192.168.1.2. It says, okay, my source MAC is CADB. I'm going to refer to it as CADB. And well, it says, okay, hey, I don't know the destination MAC of PCB. I don't know the MAC address of PCB. So it creates something called an ARP request, which looks like this. It says, okay, hey, my source IP is this, and the destination IP is this. My source MAC is this, CADB, and it says, okay, I want the IP, or I want the MAC address of this destination IP, but I don't know where it is, so I'm going to do a broadcast message. And as I've said before, an ARP request is always a broadcast message. So when this packet reaches to switch 1, when ARP request is sent over from PCA to switch 1, switch 1 will see, okay, this is an ARP request, and it's a broadcast message. So it will send out the broadcast message out of all ports except the ingress ports. It will send it over to switch 2, and switch 2 will then again send it over to PCB. At this point, PCB will see the ARP request, and it will say, well, hey, that's my destination IP, and it will know that this ARP request is for itself. So it will create another packet, which is known as ARP reply, and it will be a reply to the ARP request. And in this ARP reply, it will say, well, hey, I'm sending this packet back, and this is my source IP, and this is my source MAC. And this packet will go back to switch 2, go back to switch 1, and finally come back to PCA. And then after it has received the ARP reply, only then can it send the final data packet with the right destination MAC that it received from the ARP reply. It will be able to send the packet back. Let's see all of this happen in the actual topology. Okay, so now let's start off the demonstration. I'm going to start off by sending some data over to PCB. So I'm going to ping, just do an ICMP ping, normal ping 192.168.1.2. And just here, right now, you can see it created two packets. The first packet, well, no, let's start with that one. The first packet here is, as you can see, it's a layer 3 packet. It's a ping ICMP message. But it does not know the ARP message. It doesn't know the destination MAC address. So it creates another packet, which is basically destined for broadcast. So let's see what happens. It will send the data over to switch 1. It will send out the ARP request. And once the switch receives the ARP request, it will say, well, hey, this is an ARP frame. It's an ARP frame, and it's destined for all IPs. While it is doing this, it is also going to record the MAC address of PCA, and we can see that here on switch A, and I can show you how it knows. You show MAC address table, and now it has another entry for PCA. It sees the IP, it sees the MAC address, and it sees the port. Once it received the packet from PCA, it recorded its port and recorded its MAC address. Back to scene 1. And so let's keep following this. Let's keep following this ARP request packet. Switch 2 receives it. It again processes it, sees that it's a ARP request and it's a broadcast message. Again, it will also do the same thing of what switch 1 did. It will record the IP, or it will record the MAC address and the port. So let's go here. I can show you how it's done. Again, we are on switch 2 in show MAC address table. And as you can see, it records CADB as port FA1. You can see the port here is labeled as FA01. FA01, once it receives the packet from switch 1, it will automatically add that to its own port. And then finally, you'll see the packet reach PCB, and PCB is going to say, well, this is an ARP request. It makes the ARP reply. As you can see, it makes the ARP reply, and it will send it back to switch 2. Now, knowing switch 2, it will again now see, now this is an ARP reply, and it also sees that, hey, this PCB does not exist in my MAC address table. So now it will again include the MAC address of PCB in its own MAC address table. Now you can see a new entry for PCB on its port FA02. And it will send the packet out again because the packet is unicast and it has a MAC address. It will send it out, and switch 2 sees that, hey, this MAC address, I know where it is, and it exists on this port. It knows that, hey, this MAC address, CADB, exists on my port FO1. So I'm going to send this packet out of FA01. So it goes back and it sends it back. Switch 1 received it. Switch 1 does the same thing. It will record. It will see, well, hey, I have a new MAC address. There's a new MAC address in this table, in this topology, that has just now been discovered. And it will say, well, hey, and it's going to include the new MAC address in its own MAC address table. And it will see, well, hey, that new MAC address exists on my FA01. and it will see, well, and then the switch one also sees that, hey, this is an ARP reply, and it looks at the destination MAC, and that destination MAC is CADB, and it sees, well, hey, CADB exists on my FA02 port, and then it will finally send the ARP request back to PCA, and PCA finally has the MAC address of PCB. Now it's ready to send the data over to PCB. As you can see, the ICMP ping is going to go back, and it's going to come back. We're going to have a reply, another reply, and that's it. We have the final MAC address, and even in here, it will be able to see the MAC address of PCB. Now here you can see PCA's terminal. I'm going to do ARP-A, and you can see that it knows. Hold on. And you can see that it knows where 192.168.1.2 lives, and it lives on, well, it knows its MAC address, and it knows the internet address, and it knows it's a dynamic entry. And that's how ARP works. It's meant to resolve MAC address to IP address conflict. And another thing is that it will only do an ARP message, an ARP request, an ARP reply in its own network. Right now, both of these PCs are on the same network, and by network, I mean they're in the same IP segment. If if the PCs were in different IP segments, the ARP request will never be resolved. It will just never occur, or will never be resolved. PCA will never have an ARP reply, and it will never be able to send traffic over to PCB. That's a different topic that I'm going to cover next. So stick around. Thank you for watching. I'll see you next time.